Hello everybody, my name is Professor Soborno at Bari, and today we're going to be looking at some more physics. So, we're going to be looking at some waves today. Bye-bye, simple harmonic motion. You will be missed. Not too much, because you weren't a very interesting concept anyway. So, now SHM has joined relativity, and we're going to be looking at waves. So, what are waves? Well, we got a brief introduction to them via the simple harmonic motion unit. You probably know a few characteristics already, but there's also two types of waves. There's a transversal wave and a longitudinal wave. Now trust me, there are a lot of waves on Earth. There are a lot of waves on Earth's surface, and not just on Earth's surface do these waves lie. Waves lie all around the cosmos, specifically and most likely light waves. So, excuse me while I'm trying to draw my very garbage rendering of the world map. So, that's how I made the world map. Looks garbage, right? Because that's how I intended it to be. I draw Antarctica because we can't forget about the penguins. Those are the top part of, the Earth experience. So, transversal waves are waves that are slightly different than longitudinal waves. Who would have known? So, let's say that you have a rope, a very straight rope. Now, let's say that you kind of like shake the force that you were extending it on. Depending on when you start it, it's going to be either a sine or a cosine wave. So, a very strange thing I noticed is that if you can actually map on the sine and cosine waves onto one another if you just do something like move them in the x direction, which I still haven't figured out. Okay, longitudinal wave. So a longitudinal wave would be, okay. So a longitudinal wave, first let's explain the transversal wave. The disturbance, let's say we're in a pond, we have a pond, and we drop a rock into it. This marker is trash. Then the rock will give a big little splash that will make some ripples. Now, the rock's disturbance pointed down. The ripples pointed in all directions that were perpendicular to where the rock dropped from. So, yeah, in every direction that this downward disturbance is perpendicular to, so the disturbance is perpendicular to the effect. And for a longitudinal wave, it's not quite the same. Kind of like a little bit of grass handling a gust of wind, or dominoes getting knocked over piece by piece. So, because they're all their disturbance goes in the same force as their effect, goes in the same direction as their effect. So, a longitudinal wave would be like wheat sliding over, or dominoes knocking themselves over. So that would mean that the disturbance is actually the same direction as the. How would I say this? I don't know. I'm just going to put a hyphen here for the best of it. Okay, good. So, now that we know what a transversal and longitudinal wave is, we need some more vocabulary. What is a medium? Well, a medium is something that a wave travels through. Air, most things need a medium to travel through, except, light. There was a proposed theory that said that it had a medium, but that was proven false by the Michelson-Morley experiment. Here's an example of a longitudinal wave. See this tube? I'm going to sing Frosty the Snowman normally first. Frosty the Snowman. Frosty the Snowman was a jolly happy soul.
Do the whole thing.
I'm not really good at singing. I don't remember. Frosty the Snowman was a jolly happy soul with what was it? Something pipe mouth and a button nose and 2 eyes made out of coal. Frosty the Snowman. Yeah, I don't really remember the lyrics. So let's just do it with this tune now. Frosty the Snowman was a jolly happy soul. Okay. The children say he could laugh and play just the same as you and me. I don't know the rest of the lyrics, so I will shut up now. Okay. So, without it, you can see that my hand doesn't really vibrate. But with some sort of thing that we can feel the vibration on, my hand seems to vibrate every time I speak or yell. Ah! Yeah, it vibrates. There's some sort of force. You can try this yourself. So, since a sound wave is delivered straight and never goes in all directions, that means that sound must be longitudinal.